Okay, so let's very briefly look at hide and seek with asymptotes.
Can you put the in between the hide and the seek?
What?
Can you put an in between the hide and the seek? Nice.
It was hidden.
It was hidden.
It was hiding.
It was
In
hidden
hidden
in the
seek.
hide.
Okay, so the issue with asymptotes that I was trying to outline last time, anybody remember that?
You can have wholly asymptotes.
Yeah, there can kind of, if you're looking at a rational function, right?
And you're trying.
It can have holes, or it could also have asymptotes, or it could also have
Asymptotes hidden behind holes.
asymptotes hidden behind holes. So if I had, for instance, x squared minus 4 over x squared minus 4x plus 4.
Whoa.
Okay, and I was trying to graph this. The first things I would need to do are find out where the,
Zeros are.
yeah, so spend a second to figure out where the zeros are.
So just factor those things out. It's not really
Okay, so back to the top and the bottom. That's probably a good idea.
that's x plus 2, x minus 2 on the top.
Okay, so the top is difference of squares, so that's x plus 2 times x minus 2.
The bottom
Good.
is x minus 2 times x minus 2.
And the bottom's a perfect square trinomial, so that's x squared, x minus 2 times x minus 2.
And then just cancel, take away one of the x minus 2.
Okay.
But that's where
Care of C's right here.
Yeah, exactly.
Which
So
shouldn't,
when you
because
see something that you can onesie out,
Yeah,
right?
KFC's.
don't,
This guy, care of C's.
because it's going to be 1.
You can tell I taught this to.
Teen girls from like 2002.
Yeah, actually, I did teach this class to teen girls from 2002 once.
And they,
No, from 2007.
well, that's a big difference.
That's his favorite dialect.
It's the
Oh,
only
it's
dialect
good.
I have.
Kept
Okay,
it, and you're like, I like your dialect.
it's fine.
Alright, well, you have an
So-
infinity right there.
I have x minus 2s that I could cancel, right?
Theoretically, yes.
Okay, so what you would be saying if you say g of x is x plus 2 over x minus 2, right?
Yeah.
This is true except,
Except for that. That.
yeah, except for when this is 0 over 0, right?
Yeah.
Because x minus 2 over x minus 2 is 1, well, except for when it's undefined.
Yeah.
Right? So there really should be some kind of asterisk that says except when x is 2.
Yeah.
But x is 2 isn't allowed in this thing anyway.
Okay.
You guys see that?
Yeah.
So
That's an asymptote.
this one doesn't really need that asterisk. You see that?
But what if you plug 2 back into the top?
But isn't zero different from x over 0?
0 over 0 is definitely different than a number over 0.
Right, and so.
It's also different than 0 over a number.
Very, yeah.
Right? 0 over a number is just 0. 0 over 0 is
Undefined.
undefined,
That's fine.
and a number over 0 is an asymptote indicator, right?
Different.
Yeah, it's a different flavor of undefined.
Wow, there's multiple flavors of undefined.
There are definitely multiple flavors of undefined.
It's like Baskin Robbins of undefined.
Yeah, actually, calculus is really just a series of questions about things that would be undefined in our class, and you just kind of spend some time sorting out the different flavors, right?
Wow.
So this guy, like when I started this process, I might look and say, okay, this guy has an asymptote at x is 2, right? Asymptote at x is 2. It also has a hole at x is 2, but that's not really supposed to go anywhere anyway.
Right.
Isn't it? What else do I know about this function?
It's
It has a zero negative 2.
Okay, x is, if x is negative 2, then
Y is
the output 0.
Yeah.
Specifically, it's 0 over a number, not 0, right? So it's actually 0. So that's back here.
And it approaches the negative
What are you thinking there? You're thinking like limiting to one side or the other?
1? Yeah.
Right? So if I want the
Positive
limit x tending to infinity of g of x, right? I kind of think to myself, if I plug a really big number in there, I got like
infinity over
big plus 2 over big minus 2,
big over the big,
which is
big over 1.
more or less 1,
Yeah.
right? It's like basically plus 2 minus 2 ain't going to make much difference there. You got a really big number basically over itself. Gonna give you 1. So I have on this side at least, I think I have an asymptote going into 1. I don't know whether it's from the bottom or the top. On the other side, if I do limit x tending to minus infinity of g of x, kind of think to myself, okay, if I plug in a negative big number and add 2 and divide by a negative big number minus 2,
Positive 1.
these guys don't really contribute much.
Just like 1.
So I got negative big over negative big gives you basically 1. Something excited. So I think I've got tail end to one or the other of these. It's good with us? Make that particular YMCA dance again. Yeah, so I think this one and that one. How do you know they switch?
How do you know? I don't know, I just know.
0.
You can plot some points.
Yeah, we could plot some points, or we could think to ourselves, okay, if I look at the limit
Negative.
x tending to 2 from the bigger side, right? So that's going to look a lot like something a little bigger than 2 plus 2 on the top, and something a little bigger than 2 minus 2 on the bottom. Is going to give you on the top, like, sorry, I should be thinking this, not actually equal this. You guys don't quite have this. You don't have a tool for this yet. I'm just kind of thinking. And this would be like a number that's a little bit bigger than 4 over a number that's just a tiny bit bigger than 0.
Big number.
Which is going to give you a really big number that's
Positive.
positive. So I know from the, if I'm a little bigger than 2, I'm pointed up at the positives. If I take the limit x tending to 2 from the negative side of g of x, should be thinking a number a little bit smaller than 2 plus 2 over a number a little smaller than 2 minus 2 gives you
A little bit bigger than 0 over.
a little bit smaller than 0 over something a little bit smaller than 4.
Yeah.
So that'd be a,
No, that's
Negative 4. That's pretty cool.
Oh, no.
so this is a number a little bit bigger than 4, right? Or a little bit smaller than 4. So that's like 3.998. And on the bottom you have a number that,
Why on the top is it? Oh, because it's a little bit less. That makes sense.
yeah, so then it's like,
4, I got you.
okay, I could be
It's
like,
not negative 2.
No, that wasn't
It's-
confusing. I don't know why.
basically this is 4 over negative something, right? So that's going to give you a really big number because you're dividing by something really small. And it's negative, so you're going to get all told out of that a negative number.
Yeah.
So down here. And then you could kind of connect the dots that you have, right? So if it's down here, does it cross that asymptote?
No.
How could you check whether it crosses that asymptote or
Like
not?
in a really negative number.
No.
You set your equation equal to 1?
Yeah. You could wonder, if it ever crosses this asymptote, that'd be g of x equals 1, right? So that'd be where x plus 2 is x minus 2. Got any numbers that you add 2 to them, you get the same thing as you subtract 2 to them?
Infinity.
I think if you subtract x from both sides, you'd get 2 is negative 2,
Which is obviously true.
which is obviously
False.
definitely true never, right? This is just a contradiction. This doesn't happen. So that doesn't happen. So this thing never crosses that asymptote. So down, it starts way down here someplace, it goes through negative 2, and then it doesn't cross the asymptote, so it has to come in from the, like, can it come in from the top now?
No.
No, it's got to come in from the bottom. So that's not an option. And then on the other side, it starts up top, it doesn't cross the asymptote, so it must come in from the top. Like this.
Sweet.
Let's call that.